this lesson we are going to review how to factor and solve. We have factored quite a bit already, but we're going to now solve it. So you'll notice what's different about number 3 is in chapter 5 we would have just had x squared plus 11x plus 30. And we would have factored that and that would have been our answer. Now we have an actual equation here. So before we had an expression, now we have an equation. So the same rules apply. When we are factoring and solving, the first thing you need to do is make sure that your equation is equal to 0, which you'll see that we have in number 3. Then I'm looking at just this beginning part here, and I'm going to go ahead and factor x squared plus 11x plus 30. So I'm looking for factors of 30 when added together make 11. So first thing I'd ask myself is there a greatest common factor? There's not in this problem, so I'm going to make my two parentheses. And then I'm going to keep this equals 0 here. So factors of x squared would be x and x. And then my factors of 30 that make 11 would be, I could list them. Some of you already have that in your head, which is great. But if you want a little reminder on factoring, I'm looking for some of these that add up to 11. So hopefully you'll see that's 5 and 6. And there are my two factors. Now, one of the cool things about original problems and the degree of the problem is that in this problem, my degree is my highest exponent. So you'll notice that my degree in this problem is a 2. The biggest exponent in the original problem is a 2. That tells me how many answers I should get. So you'll see that I need 2 answers to this problem. Where my answers come from is already in my factoring. I take each factor and set it equal to 0. So what we would call x plus 5, that parentheses there, that's a factor. So I'm going to say x plus 5 equals 0, x plus 6 equals 0. So then to get x by itself, I'd minus 5, x equals negative 5, minus 6 from both sides here, x equals negative 6. So what this is saying is if I substituted negative 5 into my original problem, so that's this right here, when I substitute in here, it's going to equal 0. If I substitute negative 6 into this problem, it's also going to equal 0. The one kind of nice thing about this to look at is it doesn't really, you don't understand where these answers come from, but I want you to look at the graph of this parabola. It's a quadratic equation, so we know that this graph would make a parabola. I can tell you from just looking at it right now, the parabola goes up because the a value is 1. So take a look at this graph. That's what the graph looks like, and we could graph that. We did that in the last video lesson. My parabola goes up. What I want you to notice, though, is look at where this graph crosses the x-axis. This ordered pair is negative 5, 0. This ordered pair is negative 6, 0. Now, is that not my answers? So we're actually looking, when we solve these equations and find values for x, we are finding where the graph crosses the x values, where it has y values of 0. What these are actually called is roots. We often will call these roots. We'll call them solutions. You'll hear a couple different terms for them. I think there's a third one that I'm just not remembering right now. So we will call these roots and solutions, and it's where the graph crosses the x-axis. So what's kind of cool is you can actually solve equations by looking at the graph, and we're going to do that in our next video lesson. So for now, we're going to practice factoring, though, because factoring is a great way to solve quadratic equations. So you'll notice number 4, I'm going to look at this and say, okay, first step, my equation has to be equal to 0. Check. We have that done. Then I would look to see if I have a greatest common factor. 13's prime, so I don't have a greatest common factor. So I'm going to have to make two parentheses. Don't forget to put that equals 0 there. And I'm looking for factors of 5x squared. The only factors of 5 are 5 and 1, so I would have 5x and 1x. I'm then looking for factors of 6. So I can use 1 and 6 or 2 and 3. And one of them would have to be negative, right, because it's a negative 6. Since my middle term is negative 13, I'm actually going to try 2 and 3 first. So I'll just do like plus 2 minus 3. I'm just checking. When I multiply, I would multiply my outsides here. Well, let's just FOIL the whole thing. I'd get 5x squared minus 15x plus 2x minus 6. So when I simplify, I have 5x squared minus 13x minus 6. Did I end up with my original? I did. I got lucky. Guessed right the first time. If I didn't, remember you'd flip that 3 and 2 and we go from there. So this does factor properly here. So now from here I take each factor, so each parenthesis, I set it equal to 0 and solve. Here I'd have 5x equals negative 2. Divide by 5, so x equals negative 2/5. There's one of my solutions. Here I'm going to add 3 to both sides, so x equals 3. There's my other solution. As I look at this graph now, let's picture this graph. We would say that it is a parabola. Because a is positive, it goes up. And now think of it, it's going to cross the x-axis at 3 and negative 2/5. So try to picture that. And there's what it looks like. You'll notice that this parabola's shape is a little bit different than our other ones. You might not notice it because it's kind of zoomed a little differently. But when my a value is other than 1 and it's a 5, it changes the shape of my parabola. So hopefully you'll notice the shape's a little bit skinnier actually. So here's my 3. You can't really see it because these are, like, look at this right here. This is why you can't see this. Those are so wide. So it's going to throw off the shape a little bit just because I had to zoom in. And here is negative 2/5. So that's where my graph is crossing the x-axis. So now let's look at number 5. Here is my first one that is not equal to 0. So the first thing I have to do is subtract 16x from both sides so my equation is equal to 0. I'm going to write it in descending order. So I'd have x squared minus 16x plus 64 equals 0. And then I'm going to factor that. So I'm looking for a greatest common factor, which I don't have, but I'm going to make my 2 parentheses. What are factors of x squared? X and x. What would be factors of 64 when added together make negative 16? Hopefully you're seeing that it'd be negative 8, negative 8. So now when I set my factors equal to 0, I have x minus 8 equals 0, x minus 8 equals 0. So add 8 to both sides, I'd get x equals 8 twice. So I get 2 answers, but they just happen to be the same thing. How we write that is instead of writing the 2 answers twice, we actually call this a double root. Remember how I said where the graph crosses the x-axis, we call those roots? Well, since we got the same answer twice, this would be an 8, and it's a double root. And we will label that with dr. So again, that stands for double root. You actually can have triple roots also, and we're going to see that when we get into chapter 7 a little bit. So there's my double root. Now here's my trick question for you. Think of this graph. My parabola, because it's a parabola, right? It's a quadratic equation. It makes a parabola. My a value is 1. So since it's positive, my parabola goes up. So I'm just kind of thinking, okay, let's just sketch this. Here's a parabola. It goes up. If I only have x equals 8 double root, this answer is where my graph crosses the x-axis. So here's my x-axis. It's been crossing twice because I have 2 answers. That's why I have 2 answers. It's those reflection points. It's where it crosses. How is my graph going to just cross the x-axis at 8? Where on my parabola would it just cross one place? Hopefully, you're all screaming at your computer right now, or iPhone, or whatever you're using. The vertex. Right? Doesn't that make sense? That's the only place it could cross once. Everywhere else on here, it would cross twice. The only place it crosses the x, it could possibly have one point, if it's a horizontal line, would be at your vertex. So when you get a double root, that's telling you that's your x-coordinate of your vertex. Every time, no matter what. So that's what a double root is telling you. That's your vertex point. So notice my vertex starts at 8, and my parabola goes up from there. It does only cross the x-axis in one place, at that 8. Number 6 now, I again have to get my equation equal to 0, so I'm going to add 5x to both sides. So I have 6x squared plus 5x equals 0. First thing I always look for is if I have a greatest common factor, and I do. I have an x. Both terms have an x. So I'm going to divide both of these terms by x and get 6x plus 5. I then am going to look to see if I can keep factoring. a lot of times students will get confused when they see this because they think they should be able to keep going and say x and then have two parentheses. How you know if you can keep going or not is by the exponent on that x. In order for me to factor this, it would have to be at least an x squared or higher. I can't factor an x to the first down anymore. Or no, I shouldn't say can't. I don't need to. So this is actually in lowest terms. I'm going to take each factor and set it equal to 0. This x that I pulled out, remember how we talked about how that was the annoying sibling you never can get rid of when we were factoring expressions? I'm going to set that equal to 0. That's one of my factors. X equals 0. My other factor then is 6x plus 5 equals 0. So this one is actually solved, right? There's no work to do there. X is by itself. To get x by itself here, I'd minus 5 from both sides and divide by 6. So x equals negative 5, 6. Let's think about this parabola now. My a value is 6, which is a positive number. It tells me it goes up. And this parabola crosses the x-axis at 0 and negative 5, 6. So, might be kind of thin, huh? Oh, see how the vertex isn't much lower than that? So this parabola is crossing at 0. And then look at that, looks like negative 5, 6, doesn't it? So there are my two solutions. And it's important to connect the graph to this. I want you to be able to picture these parabolas as you're solving them and not just be thinking about what does this answer mean. Number 7, excuse me. 7 is not a quadratic equation. How do I know that? I have a cubed in there. This is not quadratic because it's not x cubed. Remember, if the quadratic equation, your highest degree would be a 2. I have a 3 here, so this is actually called a cubic equation. So does this graph make a parabola? No, it doesn't. It's not x squared. So this is actually going to make a cubic function. What does that look like? We have not done a lot of work with cubic functions, so we're kind of starting out here. You will see, if you want to see some cubic functions, in my classroom on the very left side of my posters, way like above my desk kind of, where we see all of our posters we use a lot. They're the first two posters in the front of the room, so you can see that tomorrow if you want to look at that and see what they look like. That's where you'd find an example of cubic functions. So for these, I factor them the same though. I'm going to start out and say, okay, my equation equals 0. Do I have a greatest common factor? I do. I have an x, right? I can divide everything by x. So when I divide that by x, I'd have x squared plus 12x plus 32, and then equals 0. I now look at what's left in my parentheses. Notice I have an x squared, so that tells me I probably can keep factoring. It's not a guarantee, but it means I need to try. So I'm going to look for my factors of x squared, which would be x and x. What are factors of 32 when added together make 12? Hopefully you pick out 8 and 4. So now, when I write my factors out, remember I said that this x on the outside is a factor. So I'm going to go x equals 0, x plus 8 equals 0, x plus 4 equals 0. So now it looks to me like I'm going to get 3 answers. Does that make sense? Well, we said earlier, your degree, your highest exponent, is how many answers you should have. Look at that. 3. My degree is a 3, so I should have 3 answers. So one answer is 0. One answer is negative 8. One answer is negative 4. So now, we're not really sure what this graph looks like, but I know one thing I can tell you is if this is my x-axis, here's 0, there's negative 8, there's negative 4, there's 0, right? My graph is going to cross at these 3 points. Those are my roots. That tells me where my graph is going to cross. So I can see it can't be a parabola, right? Somehow it's going to, I don't know if it's going to come from the top or the bottom, but it's going to zigzag through here and look something like that maybe. Or it's going to come this way. But somehow it's going to go through those 3 points. So let's take a look at that graph. And remember, if you wanted to look at these graphs, you could punch these in your calculator and you get the same pictures I'm getting. So here we go. I had to zoom in a little bit to see the zeros here, so I want you to know that this graph kind of goes I'm sketching it a little bit poorly. It'll look better on your calculator, so you might want to just punch this in and look at it. But that's what that graph looks like. One of the things we're going to talk about later is how when you have an odd degreed graph, your arrows go in opposite directions. Think of our parabolas. Those are even degreed, meaning x squared, it's a 2, 2 is a squared number. They go in the same direction the arrows do, whether it's up or down. Cubic functions, your arrows will always go in opposite directions. So one's going down, one's going up, or one's going up, one's going down. And, where am I crossing? There's my 0, -4, -8. So I sketched it pretty decent. I mean, I was off with the how high it should go and stuff, but that's kind of what it looks like. And there's our cubic function. Last one we're going to do is number 8. Number 8, you will notice it's set equal to 0, and I have two terms. So remember, you can either do this knowing your difference of two squares, or you can put in a 0x here when you factor. So I have no greatest common factor. I'm going to make my two parentheses. Factors of x squared are x and x. What would be factors of -16 when added together make 0? Well, plus or minus 4, right? And remember, if you're doing difference of two squares, it's always the square root of that. So when I set my equations equal to 0 and solve, or my factors equal to 0, excuse me, I minus 4. I get x to equal -4. I add 4, and I get x to equal 4. So my two answers are -4 and 4. If you want to be really super geeky, smart math person, we write it like this. Plus or minus 4. That's not required, but it is simplified, and it makes you look really smart, I think. So this is telling me that my parabola crosses the x-axis at 4 and -4. Here's what's kind of cool when you look at this. Whenever that happens, that you cross at the same number for y, that's telling me that my center would have to be at 0, wouldn't it? Because that distance has to be the same on both sides. So you could think of it as whenever you have the same number twice, so plus or minus 4, plus or minus 9, plus or minus 16, whatever it would be, your y coordinate of your vertex is going to be 0. Or excuse me, your x coordinate of your vertex is going to be 0. And that will be true every time.